All right, let's look at a quick graph problem. We can see that we're given the velocity in the x direction and velocity in the y direction of an object. And the question they're asking us for this is, which of the following diagrams could represent the forces exerted on the object? We need to understand the relationship between velocity, the variable on the y-axis of the graph, and forces. Now, the relationship is that when you have a change in velocity that is non-zero, you also have a non-zero acceleration, or zero. If you have a non-zero acceleration, you do have a net force in that direction, right? Because of the relationship that F net is equal to ma. Now, knowing all of these things, let's look at the graph. We can see in the first one for Vx that there is no change in velocity in the x direction, right? That also means that there is no net force in the x direction. For the second one, we can see a slope downwards, which means there is a change in velocity. There's a negative slope to the velocity. That means the acceleration is in the same direction. It is negative. If acceleration is negative, you also have a net force in the y direction that is negative. Now, knowing all this, let's look at our graphs. What we're looking for is a net force in the x direction that is equal to 0, and we're looking for a net force in the y direction that is essentially sort of negative or just non-zero, right? Knowing this information, look at the first graph. There is no force in the x direction, great, but the y direction, if we count the squares, which are proportional to the magnitude of the force, they're equal up and down, which means that's wrong and A is wrong. For B, we can see there's 2 units in the rightward direction for x if we break down this arrow over here, but that is wrong. There's nothing balancing it on the other side, right? Which is wrong. We want x to equal 0, net x to equal 0. So for C, you can see there's 2 to the left, and then there's 2 more from this upper arrow going to the right. Those two balance each other out. We meet the assumptions for x, but for y, we can see that there's 3 units upward and 3 units downward again. That's balanced. That's 0. We don't want it to be 0, so C is wrong. For D, we can see 2 units to the right. We can see 2 units to the left. We can see 3 units upward and 4 units down. So the x's are perfect. They cancel each other out. We want 0. For y, we don't want 0. We have 3 units up, 4 units down, and that is some negative F net, which is what we wanted, right? Also, by process of elimination,